Hello everyone. Today we are going to start with the topic derivative. So what is derivative? Derivative is nothing but small change in value of x, how it is impacting the value of y. That's what we calculate in derivative. Let's take one example. Okay. Suppose y equal to 2x plus 1. We are taking derivative of y with respect to x. So what will be the derivative in this case? 2 will be the derivative. So if here in this case derivative is positive, so if we increase the value of x, value of y will also get increased. That's what we get from here. Suppose put the value of x as 1, then value of y will be what? 2 into 1 is 2 plus 1 is 3. Suppose we put the value of x as 2, then y will become 2 into 2 floor plus 1. Y will be equal to 5 in this case. So small change in value of x, how is impacting the value of y? That's what we are getting from derivative. So derivative is positive. So if we increase the value of x, then value of y will also get increased. Let's take one another example. Y equal to minus 2x plus 1. Okay, so in this case, what will be the derivative? Derivative will be minus 2. If the derivative is negative, and if we in that case if we increase the value of x, then value of y will work inversely, so value of y will decrease in this case. If we put okay, if we put x as 1 in this case, then y will come as minus 2 plus 1, which is minus 1. If we put value of x as 2 in this case, then y will come as 2 minus 2 into 2 is minus 4 plus 1 minus 3. So small change in value of x is decreasing the value of y, as derivative is negative, and if we are increasing the value of x, then value of y will decrease. It is acting as inversely. Okay, so this is the significance of derivative in your syllabus. So where you are using derivative, you are using your derivative in physics. Okay, velocity is nothing but change in distance with respect to time. So it is nothing but derivative concept has been used over here. Acceleration is what? Change in velocity with respect to time. It is also derivative in modern education. Okay, so AIML is also example of derivative. In machine learning, there is a concept called deep learning. So there also derivative is getting used. So see, like lot of you will be wondering why we are learning this, but in future also it will be useful for you. So whatever you are learning, like give it your 100%. So yeah, you will be applying the concept for the same in future as well. Okay, now let's start with solving the real examples for derivative. So our equation is y equal to sin x into cos x. Okay, so it is in the form of y equal to u into v, right? So derivative in this case will be u into derivative of v plus v into derivative of u. Okay, just we have to apply this formula. Derivative of y with respect to x will be equal to u in this case is sin x into derivative of v. Okay, derivative of cos x is minus sin x, again plus v is cos x into derivative of u, which is derivative of sin x is cos x, which is coming as minus sin square x plus cos square x. This is nothing but cos 2x, right? Cos square x minus sin square x is cos 2x. So in this case, derivative will come as cos 2x. Let's move on to the next question. Same, see, like same formula is applicable here as well. Put u as e to the power 3x and v as sin x. Let's start solving this one. Derivative of y with respect to x. U is e to the power 3x into derivative of v cos x plus v, which is sin x, into derivative of u. What is derivative of e to the power 3x? E to the power any terms, derivative is that particular term. Okay, so e to the power 3x will be derivative of e to the power 3x, and also we have to, by chain rule, derivative of 3x is 3. So what we are getting in this case, okay, what is common, let's keep it aside. E to the power 3x is present in both, so I'm keeping it aside. E to the power 3x in a bracket cos x plus 3 sin x. This is the answer. Just we are using this formula, nothing else we have did. Okay, let's move on to a new type now. So in this case, y is u to the power v. So in this case, what we do, if the power function is there, what we can do, we can apply log on both the sides. When we apply log y in this case, and u to the power v means whatever is the power that will become coefficient. So u to the power v will become v log u. Let's apply the same one over here. Log y will come as log of x to the power x. So what will happen? Power will become coefficient. So x log x we will be getting. So let's take derivative. What is derivative of log y? It will be 1 by y, and derivative of y will be with respect to x will be dy by dx. Now it's coming in the form of u into v. So u is x, derivative of v, derivative of log x is x, plus now x is log x, so v is log x, then into derivative of u, which is 1. So answer is coming as 1 plus log x. So dy by dx will be equal to, now y will go to the multiplication from here as it is divided on the left side. Y in bracket 1 plus log x should be the answer. So the final answer, like y is nothing but x to the power x, right? Let's put it over here. X to the power x in a bracket 1 plus log x should be the final answer in this case. Let's take one more example. Yeah, so our same, right? So in this case, y is equal to u to the power v, u is sin x and v is x in this case. Let's apply log on both the sides. What will happen? Log y will be equal to, power will become coefficient, so x log of sin x in this case will come, right? Right, again we are applying the derivative on both the sides, so it will be 1 by y dy by dx equal to x log of sin x. What is log of derivative of log of sin x? 1 by sin x. And by chain rule, what is the derivative of sin x? It will be cos x, plus now what is v? Log of sin x into derivative of x will be 1. Yeah, so what is the final answer in this case? Y is in division this side, so it will go on multiplication on right side. So y in a bracket cos by sin is cot x, x cot x will remain over here, plus log of sin x. Okay, so that's all for today. Thank you everyone.